There are two major types of diagrams that the business analyst prepares during the analysis phase of the system's development lifecycle. We've already spent some time learning about data flow diagrams, which model processes. In this series of videos, we'll talk about entity relationship diagrams, which help us model data that we need to capture as part of those processes. In this video, we'll introduce entity relationship diagrams, and after the video, you'll be able to recognize an ERD, as well as describe two different purposes for ERDs. Finally, you'll be able to give examples of the major components of ERDs, such as entities, attributes, and relationships. But let's start at the beginning. We've already seen a data flow diagram, and as part of the data flow diagram, we have external entities as well as data stores. We might have questions such as, what do we need to know about a particular customer, or what information is in a vehicle order? There's also information in these diagrams that's encoded in the form of business rules. So, for example, can an offer be written for more than one vehicle, such as a fleet? This information isn't captured in data flow diagrams. Instead, we need a different type of diagram that shows the data we collect and the relationships between that data. This type of diagram is called an entity relationship diagram. This is an example of what an entity relationship diagram looks like. One of the most common notations in use today is often called crow's foot notation for a reason that might seem obvious. The lines that you see connecting the various entities on the diagram often end with a crow's foot, and we'll talk about what this symbology means as we walk through the diagram. You may have seen an entity relationship diagram before, particularly if you've worked with any kind of database software. It's important to understand that the type of ERD that we'll be covering in this class might be different than the ERDs that you've seen before as part of database software. Just like there are different types of renderings that an architect might do, for example, a design rendering that gives direction to the builders. This might include things such as where electrical conduits are, plumbing, and so on. On the other hand, the architect may do a rendering, and this is more close to what we're going to be doing with our ERDs in this phase. The purpose of analysis phase entity relationship diagrams is to gain customer approval. In other words, we take the ERDs we create in analysis phase, we run them by our business users, and we make sure that they're capturing the requirements of the process. The more technical types of ERDs, which you might see in a database class, come later in the process. That's when we add in information like data types and other fields that we may not need at the analysis level. And so what you're going to see here is largely a simplified version of the ERD notation that you might see in database software, for example. So just as there are two different types of renderings for an architect, we have two different types of ERD. On the left, you have the analysis phase ERD, which is where we'll spend most of our time. On the right, you have more of a design phase ERD that includes much more information. In a future lesson, we'll talk about how you transform the ERD on the left into the ERD on the right through a series of processes. But for now, it's just important to understand we'll be covering a simplified notation. Let's start with the core of the entity relationship diagram, which is the entity itself. An entity is a person, place, or thing that we want to keep information about. We keep examples of things like employees, students, patients. They could be places such as a store or a warehouse, or even an event such as a sale. The naming convention that I typically teach is that we name our entities using a singular noun. So for example, we might use the name employee instead of employees. And then it's important to differentiate between an entity and an entity instance. So the entity itself might be called employee, but a particular entity instance would be a specific employee, like Ken. Let's look at an example. Let's say Pet Sitters Unlimited is a company providing pet sitting services for homeowners while they're on vacation. Pet Sitters Unlimited keeps track of the data about its clients and their pets. In addition, Pet Sitters also keeps track of the family's vets and the vet's phone number. In this example, candidate entities might be things like pet, owner, veterinarian, and so on. They're the major nouns in the problem about which we want to keep information. Example entity instances might be Fido, your dog. The phone number in this case is not quite an entity of itself, even though it's a noun. it's something that would likely become an attribute, which we'll talk about in just a few slides. Next, let's look at relationships, the second part of our entity relationship diagram. Relationships are the glue that holds entities together. They're an association between instances of one or more entities that is of interest to the organization. So, for example, a product line might contain one or many products. In the top example, we have an example of a relationship in a slightly different notation where the relationship is labeled using a diamond symbol. On the bottom, we have perhaps a more common notation where the relationship is represented by a straight line and then the label is just floating in free space. We typically use a crow's foot, as you see on the right-hand side of this relationship here, to represent a many relationship. This is called the cardinality of the relationship. So in our example, one product line contains one to many products. The naming conventions for the relationship is often a verb. And so in this case, and then the verb might be multidirectional. So we'll see examples of multidirectional relationships in future lessons. Modality refers to the concept of whether a particular entity has to have a relationship with another entity. So for example, in our example here, does a product line have to have at least one product? That's a good question to ask your business user, and the result would be reflected in the entity relationship diagram. Let's go back to our pet sitting example. So again, we have Pet Sitters Unlimited, a company providing pet sitting services for homeowners while they're on vacation. Some examples of relationship questions we would need to ask are, can an owner have more than one pet? Can a pet go to more than one veterinarian? Does an owner have to have a pet? We might argue that if they don't have a pet, then they aren't an owner or a customer of ours because they don't have a need for our services. We might also ask the question, does a pet have to have a particular vet? In this case, the answer might be yes, and the answer might be no. That would be the modality of this particular relationship. Finally, an attribute is a property or characteristic of an entity or relationship that is of interest to the organization. So for example, students might have a student ID, a name, a home address, and so on. An automobile might have a vehicle ID, color, weight, and so on and so forth. Now, it's important that we not just brainstorm all of the things we could potentially keep track of. Instead, we want to focus on only those attributes that are of interest to the organization. It's very important that you work with your business users to narrow down the amount of data that you collect, both for legal reasons as well as practical reasons. In addition to kind of brainstorming or listing out all the potential attributes, it's important to identify a candidate identifier. This is a particular attribute that would make each entity unique. Usually, we come to settle on a specific number. So students might have a student ID, employees might have an employee ID, and so on. This is because other attributes, like someone's name or even address or phone number, aren't unique to that person, and we need a way to uniquely identify each entity in our list. So, this is the complete picture of an entity relationship diagram with the basic components. We've covered entities, which are represented by the boxes you see, relationships, which are the lines, and attributes, which are listed in each entity itself. In future videos, we will dig into this notation in greater depth and look at some advanced modeling scenarios. Now that you've seen your first entity relationship diagram, let's take a look at some of the more advanced features that you might see in some of these diagrams. In this video, we'll take a look at the concept of an intersection entity. An intersection entity helps combine two or more entities and capture attributes about the relationship among them. After this video, you'll be able to define the term intersection entity in the context of ERDs, as well as describe real-world situations that we might model with an intersection entity. Finally, you can define a foreign key and determine whether or not to include foreign keys in your ERDs. Let's go back to a representative entity relationship diagram. In this diagram, we're modeling a clinic where doctors might see patients at an appointment for particular symptoms. We're going to use this example to dig into the concept of an intersection entity and when you might want to use one. For example, let's look at this relationship. As part of talking with the business users, you might determine that a patient can present 0 or more symptoms, and a specific symptom might be associated with 0 or more patients. We've represented that here on the diagram. If we read from left to right, we go from patient to symptom. We see a little circle or oval followed by a crow's foot on the symptom side. We read this by saying a patient can have 0 or more symptoms. And going the other direction, if we read from right to left, we can see that a particular symptom that is described by a symptom name and description could be associated with 0 or many patients. So for example, 0 or many patients might have a stomachache. Now the question becomes that when you have a many-to-many relationship like this, you can also recognize it with the crow's foot out notation, is that there might be more attributes in here that we need to keep track of. For example, when a particular patient had a particular symptom. In this case, we would use a special entity called an intersection entity. It would look something like this. We take the crow's foot out notation that we saw in the previous slide. We would add an extra entity in the middle, and then we would effectively invert the notation so that now the crow's feet are pointing in towards the new entity, which is called an intersection entity. Now, there are a couple choices you have to make when putting an intersection entity into your diagram. The first is what to call it. And you have a couple of options here. The first and kind of most obvious option is to essentially glue together the names of the two entities it relates. So in this case, you have a patient symptom. That's just the names of the two entities put together. The second option is a more realistic name. So you might want to think about what that intersection represents. We'll see an example in a little bit where the intersection actually represents a sale, and in which case we'd call it a sale. And then you have a couple of options as to how you identify that intersection entity. One would be to give it an arbitrary ID or number. In this case, it might be an example like a transaction ID that we often get when we make a reservation for a hotel room or even when we buy something at the supermarket. The other option for an identifier is to effectively take the identifiers from the related entities and concatenate them together. The specific details of all of this we'll kind of gloss over for the moment. However, there'll be some questions and activities that might ask you to dig deeper into this concept. So let's take a look at another example. In this case, we have an item that could be part of 0 or more sales, and when you have a sale that has to have 1 or more items. So again, reading the diagram between item and sale from left to right, we see on the sale side of the relationship, the oval represents a 0 modality, effectively meaning that an item does not have to be part of any sale. So it could, for example, just be sitting on the shelf without having sold any of them. And then the crow's foot means that a particular item might be part of 1 or more sales. Reading in the opposite direction between sale and item, you can see that on the item side of the relationship, there is a vertical bar there. That means that a sale has to include at least 1 item. And then the crow's foot means that a particular sale could include more than 1 item. Taken all together, this is a many-to-many relationship. So again, we see kind of a crow's foot out notation, and that's our clue that we might need an intersection entity in this case. And so what do? We put the intersection entity in the middle, and we then change our notation so that the crow's feet on the notation points in towards the new intersection entity. We then borrow the identifiers from the related entities, so we include the sale ID and the item UPC, which are the identifiers of the related entities. And then we can put any additional attributes that we might want into this entity. One example might be the date and time at which that particular item was sold. So this describes where the instances where we might want to use an intersection entity to capture additional information in our data model. In future lessons, we'll take a look at additional, more advanced notations to capture special purpose situations that we might want to model. In typical systems, many of the entities about which we want to track data share certain common attributes. For example, employees and customers both have names. It's important that we model these in a correct way so that we kind of optimize the structure of our data and we're not having duplicate data. In addition, employees might have different roles within the organization. For those roles, we might want to track different types of data. Once again, it's important that we model these efficiently and correctly so that we can optimize the structure of our data in our system. In this video, we'll talk about the use of subtypes and supertypes in order to improve our modeling efficiency. After this video, you'll be able to describe the purpose of subtypes and supertypes in an ERD, as well as read ERDs containing subtypes and supertypes. Finally, you'll be able to define the 4 different types of subtype-supertype relationship, sometimes called a generalization relationship. First, let's look at our checklist of things that we'll cover related to entity relationship diagrams. We've talked about entities, relationships, and attributes. Within the context of entities, we've talked about intersection entities and their role in resolving many-to-many relationships. Within relationships, we've talked about cardinality, which determines whether something is limited to one or a many relationship, and modality, which determines if a relationship is required or not. And finally, when we introduced attributes, we talked about the importance of a candidate identifier. Now let's talk about subtypes and supertypes. And in a future video, we'll talk about how to model hierarchies in an organization. Let's take a motivating example. First, the diagram you're looking at might look a little bit different to you. That's okay. We've introduced ERDs, and primarily we use what's called a crow's foot notation. This is the most popular. What you're looking at here is still an ERD, however this is called Chen notation. This is actually one of the original notations developed by Peter Chen in the late 70s at IBM. This notation is a little bit more verbose, but it still contains the same information. In this notation, we have entities represented by rectangles, like you see here, physician, patient, and so on. Our attributes are connected to the entities by a line and are represented in ovals. So a patient, for example, has a patient ID and a patient name. And you can see the candidate identifier is underlined. Finally, relationships are labeled with the diamond notation, which you see in the middle here, at the patient treatment. Other than that, this notation communicates mostly the same information. It just takes up a little bit more space. Let's use this to talk about how we might want to introduce subtypes and supertypes. So for example, I want to extend my model to allow physicians, nurses, physical therapists, or pharmacists to provide a patient treatment. What changes will we make? Well, in this case, the physicians, nurses, physical therapists, and pharmacists all share certain attributes. For example, they all have names. They probably all have an employee ID and so forth. But there might be additional information that's specific to each one that we want to keep track of. This is the kind of situation in which we'd want to model this relationship using subtypes and supertypes. Subtypes and supertypes are often called a generalization relationship. This shows that one entity, the subtype, inherits attributes from another entity, which is called the supertype. This means that all attributes of the supertype are also valid for instances of the subtype. So for example, all of our various treatment options might have a name, for example, and a home address. This is how we might notate a subtype-supertype relationship. We create a generalized type on the left here, which you see we're going to call caregiver. We extract the common attributes, such as their ID, their name, and anything else that might be common, and we put that in the caregiver entity. We then leave for the individual types, such as physician, nurse, physical therapist, and pharmacist, any attributes that might be specific to those individuals. Caregiver in this case is the supertype, and physician, nurse, physical therapist, and pharmacist are all subtypes in this example. Now, there are a couple of choices that we need to make about this relationship. The first is the specialization total or partial? In this example, if it's a total specialization, that means that a caregiver can only be one of the 4 types you see listed here. There are no other types of caregiver in our organization or in our business that we want to model. In a partial specialization, a caregiver might be one of the four that you see here. However, there might be other types of caregiver that we choose not to model. In this case, it's called a partial specialization. We typically note that on the diagram by drawing 1 or 2 lines at the location you see here. As modeled on the screen here, this is a partial specialization with just 1 line connecting caregiver to the circle that you see. In this partial specialization, effectively what this communicates, or in other words, the semantics of the diagram that you see, is that we might have another type of caregiver other than the 4 you see listed here. Another dimension of this relationship deals with whether the relationship is disjoint or whether it's overlap. In a disjoint relationship, if an entity instance of the supertype is a member of one subtype, it can't simultaneously be a member of any other subtype. In plain English, this means if someone is a physician, they can't also be a nurse or a physical therapist. If the relationship is overlap, that means that someone can be more than one of the types. So we might have a physical therapist who is also a nurse, for example. We indicate whether the relationship is disjoint or overlap by simply putting the letter D or O in the circle you see here. As shown, the relationship here is ambiguous, and you'd probably need to see one of your business users to determine whether this should be modeled as a disjoint or an overlap relationship. So we've covered the 4 different types of specialization, which is total, partial, disjoint, or overlap. And we've covered some instances in which you might want to use specialization. In a future video, we'll take a look at one final situation that's tricky to model, and that is modeling a hierarchy. We've looked at many aspects of data modeling. We've introduced entities, attributes, and relationships. We've talked about intersection entities, as well as talked about when you would want to use subtypes and supertypes. Let's take a look at one final situation that often comes up when trying to model an organization, and that's the concept of a hierarchy and how we represent a hierarchy. After this video, you'll be able to define a recursive relationship in the context of ERDs, as well as describe situations that can be modeled by a recursive relationship. At the end, we'll wrap things up by talking about how we balance our ERD with our DFD to make sure that we haven't missed anything. Let's look at our checklist of concepts regarding entity relationship diagrams. We've talked about entities, relationships, and attributes. Let's take a quick moment to review intersection entities. Intersection entities occur when we have a many-to-many relationship. We then resolve that relationship by putting in an intersection entity. In the example here, these 4 entities are all examples of intersection entities. You can also see in this example diagram they haven't done a good job of cleaning up something called foreign keys. The foreign keys are when you take the key of one entity and put it in another entity, like the intersection entity. For example, you see here under the customer favorite, which is an intersection entity, the customer number, which is the key for the customer entity, appears in customer favorite. This is an example of a foreign key. If you've worked with relational databases, you're probably familiar with the concept. While this diagram shows them, I actually don't recommend including your foreign keys in analysis phase diagrams for a number of reasons. First, they aren't generally relevant to your business users. You generally will generate more questions than answers by including them. Second, with the prevalence of non-relational database technologies these days, it's not even clear that it will eventually be needed. The entity relationship diagram that you draw in analysis phase might be transferred into a non-structured database or non-relational database during the design phase, in which case the foreign keys aren't needed. If you don't know what a foreign key is, then you're probably okay. You're not in danger of adding them into your diagrams. These 4 intersection entities combine to create more than one relationship, in this case 4 different relationships, between a customer and a particular tune in the store. That tune could be sold to the customer, it could be their favorite, they could be interested in it, or we could be making a targeted promotion of that tune to that customer. These intersection entities define 4 separate relationships between a customer and a particular tune. Now let's look ahead at modeling hierarchies. This is the last concept that we'll cover related to ERDs. First, let's take a motivating example. In this ERD, product refers to a finished good that's sold to a customer, and demand is driven in this case by the master schedule, which is represented on our diagram by an entity. An item, on the other hand, is a purchase part, purchased from a particular supplier. And you can see that a product is composed of many items. The limitation of this model, however, is that an item effectively cannot be sold in and of itself. So there's no way, for example, to sell sunglasses as well as selling, say, replacement lenses for those sunglasses. In this case, we might model this situation with a hierarchy. We model hierarchies using a concept called recursion. Now, warning, recursion can be a little bit brain-twisting at times. Recursion involves relating an entity to itself. Let's take a look at a couple of examples. In this case, the most common case that you see in most textbooks for a recursive relationship is an employee. Employees are often managed by other employees, and then certain employees are managers who manage other employees. We see this represented by the model on the left. The relationship between an employee and itself is effectively a one-to-many relationship. So employees typically have 0 or 1 manager. That's reading the direction is managed by. If we read the manages direction, we see an employee manages 0 or more other employees. Going back to our item and product model, we might better model that using something like what you see on the right here. An item is an assembly of many other items. If we read it in the other direction, we can see that an item is a component of 0 or more other items. This allows us to effectively model the concept of subassemblies. So for example, we might make subassemblies which are then assembled into a final finished product, such as a bicycle. There are many other business situations that involve recursion. In examples and exercises associated with this lesson, you'll get the chance to exercise this a bit. That wraps up our discussion of the main concepts of entity relationship diagrams. You should now be able to effectively read these diagrams. Creating them will take a little bit of practice. Even after 20 years, I haven't really mastered it. Let's wrap up by taking a look at the relationship between ERDs and DFDs. ERDs model data, while DFDs model processes. On the left here, we have a data flow diagram for our doctor's office, and on the right, we have a sample ERD, or entity relationship diagram, for the same doctor's office. The relationship between the two is not specific, but usually data stores and external entities in the DFD on the left become entities in the ERD on the right. So, for example, we have a D1 patient's data store in our data flow diagram, and you can see we have a patient entity in the ERD on the right. On the left, our data flows usually become attributes. Data flows in a DFD represent the information that is flowing between those particular processes. This information is usually represented on the ERD by attributes. It's important to remember that this is not a hard and fast rule. Rather, I recommend that as a business analyst, you review the two diagrams after you've created them for any inconsistencies. It might be okay, for example, if an external entity does not appear as an entity in the ERD, but you should be thinking about that and be trying to catch that. This wraps up our discussion on ERDs, and in fact our discussion of the analysis phase in general. As we move ahead, we'll start to look at design phase and the role that the business analyst plays in this phase of the project.